Welcome back, guys. Here's an integral that's a bit easier than it looks. It's 1 over the square root of x times x plus 1. It's on this web page called Tough Integrals. It's not that tough really, but I suppose to know the trick, you use this substitution u equals root x, and it's quite clever. You end up with 2 arctan root x plus c. Now I'm just going to, I wrote that down on a piece of paper, you'll see in a minute. I'm going to use that in an AI to see if I can solve it, and I'm going to show you how good the LaTeX output is as well. I've solved all those problems. So I'm using two AIs. I'm using a text-based AI, and that's good at maths, but it can't see anything. I mean, of course I can type this integral in and it'll solve it, that's no problem. But I'm going to go one stage further because I'm going to have images, and in the images I'm going to photograph the equation which I've just handwritten, and to see if the second AI, which just does images really, it does other things but it's best at images, can actually give me the what's on the paper. Now I don't want it to solve the problem because it's not that good at maths. So what I'm going to do is just pass that information to the text-based AI and get it to solve it for me. It's a little bit flaky at the moment, but that's going to do that. And then I'm going to just point my camera. It's just a normal webcam at a whiteboard down here in the basement, and I'm going to get it to read what's on there. I'm not going to get it to solve anything because I've already done that, and that'll be it, so hopefully. Okay, let's get on with the demo. So here's the new program. On the left here is the text output window, and that's actually going to have, also does real-time LaTeX, which is quite impressive when you see it. It really flies up the equations, and I've really got the equations working a lot better than they were, because this isn't working on a web-based program anymore. This is just running, everything's running locally on the PC. Because of that, I'm going to use sci-fi voices, which are the sci-fi voices, which are the default for a PC. And because there's two AIs, I'm going to use an English AI, which is Sarah Proc William. Now that Sarah Proc's the Edinburgh company that makes these voices. You can buy them. So the English voice is going to be the voice of what I call Zen, which is a text-based AI. It doesn't do images. So because of that, I need another AI, and that other AI is going to be called the Guardian, and that's got an American accent, and you'll hear him speaking. And when you hear him speaking, this will go blue. It's a bit sort of schizophrenic, and sometimes I want to talk to the vision assistant and it won't let me. It jumps back to Zen, as you'll see. I can also transfer information, in text from one to the other from this button here. I just do it manually at the moment. I put a bit of echo on just for sci-fi effect. I'm not going to put the, you've seen it before anyway, the avatars on flashing around. I'll just leave it the way it is and we'll get started. Hello, who are you? Hello, who are you?
Hello, I am Zen, an advanced AI designed to provide information and assistance across a wide range of topics. How can I assist you today?
Start the camera. Take a picture. Describe what's in the picture.
The image shows a handwritten mathematical equation on a piece of lined paper. The equation is, equation below the equation, there is handwritten text that reads, equation. The paper is placed on a surface with a red and white patterned background.
Solve the equation in the image.
Of course, please share the equation or describe the image so that I can help you solve it. You can type out the equation directly or provide a detailed description of what's in the image. Thank you for providing the details of the image. The equation given is equation. To solve this integral, we can use a substitution method. Let's proceed step by step. Step 1. Substitution. Let equation.
You can see how it breaks it down, eventually gets the right answer. That's the answer you'll find that was on the web page. It is the right one, 2 arctan root x plus c, so it gets that right. No problem at all. Let's move on to something else. I don't know if it'll be able to do this, but let's see. It's an eigenvalue problem, so I'll just start it up again. Take a picture. Explain what's in the image.
The image shows a handwritten mathematical problem on lined paper. The problem reads, find the eigenvalues of the matrix A equals 2, 0, 4, 5. The matrix A is written as a 2x2 matrix with elements 2 and 0 in the first row and 4 and 5 in the second row. The handwriting is in red ink.
In the image, can you solve the equation?
Yes, I can solve the equation.
In the image, can you find the eigenvalues?
Yes, the image contains a question asking to find the eigenvalues of a given matrix.
Can you go ahead and do it? Stop. Now you see what's happened there is it's got its history, it's got a bit mixed up. It's still thinking about the previous problem. So what I'm going to do is start it up again.
Certainly, to find the eigenvalues of the matrix equation, we need to solve the characteristic equation, which is derived from the determinant of equation. Here's a step-by-step breakdown. 1. Form the matrix equation. Equation 2. Calculate the determinant of equation. The determinant is given by equation simplifying. We get equation 3.
So that was Zen, the English voice, solving the problem. The vision assistant didn't there. Sometimes it can actually solve problems, but other times it isn't really not that successful. Let's just put some state space in front of it now, so I'll start it up again. Take a picture. Describe what's in the image.
The image shows a handwritten mathematical problem on lined paper. The content includes a system of differential equations, a Laplace transform, and matrix calculations. Specifically, it involves the following: 1. A differential equation, equation 2.
Okay, stop.
A Laplace transform.
Stop.
The image contains a mathematical system described by a set of equations and matrices.
List the equations in the image. And it's listed them. It's not said much about them, but these are the equations that I wrote down in the original thing. Start the camera. Take a picture. Describe what's in the picture.
The image shows a whiteboard mounted on a wall in a room. The whiteboard contains handwritten mathematical equations and a smiley face drawn in the top left corner. The equations include 1 r use n, 2x equals ax plus bulletin, 3y equals cx, 4x equals indefinite integral e caret at. The room has a dark curtain on the right side and a small portion of a fan is visible.
Stop. In the image, can you tell me what equations those are?
The equations on the whiteboard are related to linear systems and differential equations. Specifically, they appear to be 1 equation 2, equation 3, equation. These equations are typically used in
okay, so it's basically missed the C out, but that's about the only thing it's got a T, yeah, it's important. Yeah, it's got y of x other than y of t, and that should be dx. No, that is dt because it's using t instead of tau. At. So that's actually right, but it's just missing the c out in front of the equation, if I remember properly. So actually, that's pretty good. Let's try it on another equation. It's much harder. It's going to be a differential equation. Take a picture. Describe what's in the image.
The image shows a handwritten mathematical problem on lined paper. The problem involves a differential equation and an initial condition. The equation is equation with the initial condition. Equation. The problem asks to solve for equation in terms of equation.
Can you solve the differential equation in the image?
The image contains a differential equation and an initial condition. The equation is equation with the initial condition. Equation. To solve this differential equation.
Okay, as you can see, it doesn't always want to, that's the image one, it doesn't always want to solve things because it kind of just does images. Sometimes it has solved things and sometimes it hasn't. But I've copied what it said down onto the text box here, and I'm going to send that to Zen and it should be able to do it.
To solve a differential equation with the initial condition equation, we can use the method for solving first-order linear differential equations. This particular equation is a separable differential equation, which means we can separate the variables equation and equation. First, rewrite the equation. Equation, rearrange it to separate the variables. Equation. Now, integrate both sides. For the left side, we need to integrate with respect.
That's quite amazing actually, because I think certainly in steady state, that's the right answer, because when t goes to infinity, it's a divide. What that is the equation of a divider circuit. And when t goes to infinity, the output goes to 1 upon u, which is the input. Otherwise, the reciprocal. I think that's right. Because, yeah, 1 is the numerator term and u is the denominator. So it should be, I think, it goes to 1 upon u. Yeah. So it's managed to solve that. Took its time to speak it because there's quite a lot in there. Basically, that's it solving a differential equation as well. It's nice layout. The way it's done it is different to how I tried it in the past. In the past, it used an integrating factor. This is the way that I solved it myself, just my separation of variables on either side and integrating both sides. There you go. Good, eh? And maybe we could try it on something else, like some music. See what it thinks of that. Take a picture. Describe what's in the image.
The image shows a sheet of music, specifically a piano sheet with both treble and bass clefs. The music is written in the key of C minor CM and includes chord symbols such as CM7, DM7, F7, and beat Maj 7. There are lyrics partially visible, including phrases like "I left my heart in San Francisco" and "High on a hill." The sheet music appears to be part of a song, with a slow...
And that's correct, isn't it? C minor, let me think. That would be equivalent of E flat, isn't it? Which, yes, two flats, B flat and E flat. Yeah, that's right. Yeah, and of course it starts in C minor. Yeah, if my music theory is right, just off the top of my head, C minor is from E flat is the relative major, which goes down 3 semitones. That's D, D flat, C, C minor. I always get confused with C sharp minor, but yeah, that's right. So he's got that right as well. Unfortunately, he can't write any music or anything really cool like that. But we can try it on just very basic objects and things on the desk here. Not much here, but let's go. Take a picture. Describe what's in the image.
The image shows a tabletop scene with a variety of objects. On the left, there is a globe with a blue and white color scheme, mounted on a black stand. Next to the globe is a can of Pledge Rapid Polish, which is a cleaning product. The can is predominantly black with red and white text and a logo.
It got the polish wrong. That's actually fly killer, but never mind. Let's just do a basic image because it does them as well. We can do, I don't know if it'll work, but we'll do food. Okay, we'll do that one, see what it does. Describe what's in the image.
The image shows a bowl of noodle soup with a soft-boiled egg cut in half, revealing a runny yolk. The soup is garnished with green onions, edamame beans, and what appears to be a dark, spicy sauce. The bowl is placed on a wooden board, and there is a small bowl of the same spicy sauce on the side, with a spoon resting in it. The background includes a gray surface and a green napkin partially visible on the right side of the image. The overall presentation suggests a warm, comforting dish, likely of Asian cuisine.
Well, finally, I'm just going to do some basic maths and see what else it can do, some interesting stuff, see what it can come up with.
Of course. I'd be happy to help with your math problems or any other questions you have.
I forgot that I had it on, never mind. Give me a table of Z transforms.
Certainly. The Z transform is a fundamental tool in digital signal processing and control theory. Here's a basic table of common Z transform pairs. Common Z transform pairs 1. Unit sample impulse equation.
It's done that. It's quite interesting. Seems that's right. Off the top of my head, I can't see how many of these are correct or not. That looks right. Geometric series. Oh, Z, A to the n, Z over Z minus A. Unit step, Z over Z minus 1. So on. Let's try Laplace transforms now. Show me a table of Laplace transforms.
Certainly. The Laplace transform is a powerful tool used in the analysis and design of control systems, signal processing, and other fields. Here's a basic table of common Laplace transform pairs.
So that's the Laplace transform. Step is right, that's right. I think that's right. Cos, sine, it looks something. Yeah, I think it's right. I have to check it. That's definitely right. The ramp 1 upon s squared. Triangular pulse. Sure, that's right. That should be 1 minus e to the minus st. Now it's a little bit more complicated. I'm sure about the sync integrate. Let's ask it what convolution is. What is convolution and how is it applied to linear time invariant systems?
Convolution is a mathematical operation that expresses how the shape of one function is modified by another. In the context of linear time invariant LTI systems, convolution is used to determine the system's response to an input signal.
Let's have a quick look at that. Doing this live, so I haven't checked it. That's right. T minus 2. Yeah, that's right. That's from infinity. Not only have to integrate from infinity to minus infinity, but never mind. Depends on the interval. Let's give it an example. Substituting, yeah. B minus 2. So the B, where the B is coming from there. Seems to have introduced unnecessary complication. Basic idea is right. Show me a table of Fourier transforms and describe what application they have.
Certainly. The Fourier transform is a fundamental tool used to analyze signals in the frequency domain.
Let's try something else. Oh, it's listening to me.
Of course, what would you like to do or talk about instead, whether it's exploring a new topic, solving a puzzle, discussing philosophy, or anything else?
Start camera. Take a picture. Describe what's in the image.
The image shows a book titled Chopin, The Reluctant Romantic by Jeremy Seidman. The book cover features a portrait of Frédéric Chopin, a famous composer. The portrait is painted in a classical style, with Chopin depicted in a dark coat and white shirt, looking slightly to the side with a thoughtful expression. The book is placed on a wooden surface, partially overlapping a keyboard and some papers. The background includes a red textured.
You got that right.